there. All right. All right, good morning, guys. How are you?
Great morning. Good morning.
Good morning. Wow, John's ready to roll. All right. Well, I hope you enjoyed last night. The mariachis, I hope you had fun and are not too destroyed this morning. I see a few people are still not here yet, so I'm guessing they are destroyed. But anyways, today is day 2. So hopefully you'll enjoy this day as well. Very packed with lots of great cool stuff. Today's session, starting off today, will be Mr. John Clausen over here and Mr. Brad Wood. They will be talking about evolving the elephants. So the legacy health problem, how to attack and how to partition it, how to build microservices around it, and how to actually decouple all these monsters into modern times. So without further ado, Mr. Bernardo Maderas. Gracias. Good to go. Excellent.
All right, well, welcome everybody. Today, we're talking about evolving elephants, teaching them to fly. So, people are writing new applications in ColdFusion, but the reality is a lot of the applications that are out there today, especially that we interact with our clients, are legacy applications. When you have a language that's 20 years old, there's a few languages that are that old, some that are older. Statistically, a lot of the code out there is not going to be fresh, new code. Not every developer gets to work with a brand new project every week, right? Sometimes you probably wish you could throw whatever you have in the dustbin and start over, but it may be huge. So this is sort of I don't know if I want to say the next big thing, but this is where ColdFusion developers are focusing. We have a lot of people coming saying, we want to get off of this legacy hell that we're in. We want to upgrade, we want to modernize, but we don't know how to do it. It's just such a big elephant. How do you eat the elephant? As I always say to Luis, one bite at a time. That's how you eat the elephant. So I'm unclear if the elephant's supposed to be evolved or eaten, but maybe it evolves first as you eat it and figure it out. So let's just talk for a minute about some familiar looking images of what your applications probably look like in the world of spaghetti. Right? So, some of you guys probably have some apps that look a bit like this image on the right. We call this spaghetti code, right? This is how I started developing ColdFusion. Back when I barely even knew what it was. My first ColdFusion application was in one file. I thought it was really cool. It was all index.cfm and it was an entire application, right? It was a horrible idea, but at the time it seemed really nice. There was a lot of spaghetti, right? In that. So it's quick and dirty, right? We can hammer out our applications. Everything's just all jumbled together. Display logic. It's a monolithic app design, especially if it's one file. Very monolithic. There's no separation of concerns, and you can't scale this. You can't extend this, right? Anybody saw apps that look like that? This is just the first slide. Oh my gosh. All right, so this is our next step, right? In the early 2000s. ColdFusion MX6, we started getting things like objects, CFCs. So we began to add an object-oriented code on top of our meatballs, right? So there's our meatballs. Those are kind of our little service layer we started kind of trying to stick into our legacy applications. So this organized a bit of logic. Maybe you could have called it service-oriented, some abstractions. It's still kind of a monolithic app design. It's still on top of spaghetti, right? But at least we got a few kind of chunks of stuff going on. But it's still difficult to scale, even the spaghetti with meatballs, as much as I like to eat them. So around 2005 or so, the rage was MVC frameworks, right? Model view controllers. So now we started making lasagna apps, where we kind of turn stuff into horizontal tiers, if you will, right? Now we finally had some decent separation. The meatballs are still in there, right? Our service layer, but they're all kind of at the same level now. This helped enforce object-oriented design. We could have specialized team members, like a front-end guy who could just work in the views folder, right? That's where the HTML was templated. A back-end guy that could work with DAOs because we had that kind of separation. It still came with tight coupling, though, between the layers. Then it kind of became popular in tier applications, right? This is a 100-layer piece of lasagna. It doesn't even look that appetizing. So we'd add layers upon layers, but they were still tightly coupled, and you can still have a monolithic app design even with layers. Just adding layers up to the moon is still one giant application. And sometimes your applications have the surface area of this world's largest lasagna, right? I mean, how many people have an application that just has probably 1 million lines of code in it? It does so much stuff. It's got so many handlers, so many views. And I mean, this is a real-life application, right? When you get out of hello world land, this is the kind of apps that some people have to manage. We have a lot of complexity, so much code. Nobody really understands the whole application, and it can be too big for your plate, right? This is still difficult to scale because it's still a giant piece of lasagna. So the ideal scenario then is modularity ensues, as I like to say. And my favorite Italian food is toasted ravioli, right? And this is our ideal image of microservices. Small, containable pieces. Each piece of ravioli has meat, it has cheese, it has pasta. I'm getting hungry just talking about this. I don't know about you guys, right? But I can add a piece of ravioli to the plate. I can take it away. We can scale this. We can vary the number of pieces of ravioli. They have very distinct API. Drop-in functionality. It's reusable. You can have different teams of people working on different parts of your application with this. This lines of separation and the interaction between the pieces are much more defined now. And it's also easier to distribute, like into my stomach. So bite-sized pieces, right? A lot of our apps kind of look like that Swiss Army knife, which I would, if I had that, I'd carry it around, man. I would use that sucker. But a monolith can only really scale up when you have a server and you just keep, adding hardware to it because it's one big application and you can't really spread it out. So we have to find logical areas to be able to break up our applications. Where's the dividing lines of where we can break pieces off and separate them out to be able to containerize, separate your app and become more microservice oriented. So the smaller the pieces you have, the easier you can scale out. We use a phrase called cohesion and coupling, right? And usually this is used to refer to object-oriented design, but I thought it also could be applicable here. Cohesion is like-minded pieces of your application, things that naturally should come together, same as the science world, right? So if you have a bunch of different things sending mail around your app, those are sort of a cohesive, piece of functionality. They're doing one thing. Maybe you're generating several PDFs in different places. Those would kind of, cohese together. They're one kind of similar concern. Coupling is how tightly one piece of code is dependent on another piece of code. Back in the day when everything went in index.cfm and we had a variable scope that just transcended the whole page, we had incredibly high coupling because a variable being set up here had to exist down here. When you tried to, break a chunk of code out, stuff would break, right? That's very high coupling. So on the left, we have low cohesion and high coupling, and this is not where we want to be, right? We've got triangles, we've got rectangles, we've got squares, just kind of mixed all over the application. Nothing's organized very well, and the lines represent the dependencies, the coupling between the different pieces of the application. The image on the left is harder to scale out, it's harder to break pieces off, it's harder to reuse things and to swap out functionality because the coupling is very high. You try to take out a square and you break all those lines. On the right side, we have high cohesion and low coupling. You see how the circles are grouped together, the squares are grouped together, the triangles are grouped together. This is your application naturally putting pieces of functionality that go together in the same bucket, if that's modules, if that's microservices, depending on the layer you're doing this on. And the coupling is reduced. See, we have just one line between each box, a very well-defined API of interaction point of where this piece of code is going to talk to this piece of code. And the image on the right is where we want to be because that allows us to scale better. That allows us to understand what a chunk of functionality does and swap it out or maybe spin up 4 of them to handle more load. And we did this a few years ago with the ColdBox platform. In ColdBox 3, we had a monolith. We had a platform, an MVC framework that did all kinds of stuff, but it was really big. So we turned it into ColdBox 4, which reduced the core size, and we started carving off pieces of the framework, things that were standalone, cohesive chunks that could be moved over here, and the coupling is reduced to this is a service, this is the API, and this module is now entirely optional. And this is what we did with the ColdBox 4 framework. We broke out validation, debugger, internationalization, the ORM services. And this is the same idea of what we do with our applications. So how do you start trying to figure out, how would I begin cutting apart a massive application? What we like to do is to create some sort of module map or mind map of your application, right? Sit down and just start drawing boxes. And the first box is our app, right? And you just think we have a shopping cart piece, we have an API piece. Start breaking it out into chunks. So you can kind of, as with your team, you can get an idea of what the main areas of functionality are in your app, and you'll probably kind of rearrange the graph as you go. This kind of actually belongs over here, and that's kind of the cohesiveness happening. You're figuring out where are the pieces of my application that fit together, and this is going to be your roadmap for what you can start carving off into separate functionality, what you can start scaling out as maybe some sort of separate service. Ideas might be some sort of web-based administrator. The ContentBox CMS is an example of this. You can, and the Lucy CFML engine as well. They both have a web-based administrator that's modular and can be uninstalled. So if you want a secure production install, it's been completely moved off into a separated chunk that can just be removed from the application. An API is a super common example of this. This is why we push for people to write ColdBox APIs inside of a module. Because if they want to move that API somewhere out to a microservice and decouple it from the main application, it's completely modular. It's a self-contained folder of code. PDF generation, image manipulation, some sort of standalone processing, maybe even the blog on your website. These are all potentially chunks of an application that could stand on their own and be scaled independently. So with that setup, John's going to come up and give us some more in-depth ideas about how we can make that happen with our tools.
So quick sampling in the room. How many in the room have been developing with CFML for at least 5 years? 10. Keep your hands up if you're 15. 20. Ray wins. Wasn't oh, you got to do the math.
CF3.
Okay, yeah, that's it. Yeah, that's gonna be right around that. So, we've got a lot of folks who've spent a lot of time and have seen the evolution of the tooling. We've seen it get better. We've seen a lot of improvements in the underlying engines. We've seen open source engines. So there's a lot of shared experience, and sometimes it feels like the next new thing's coming down the pipe, and we just want to say, hey, I think I'll just hold off and wait for the next new thing because I've been down this road. This isn't my first rodeo. The reality of it is, though, with regard to legacy applications and portability of the language that we collectively use to develop applications, there has never been a better time to look at service-oriented architecture and microservices patterns in our applications. So yesterday's paradigm, and many of you are familiar with this. This is just review. Yesterday's paradigm was effectively, the big old messed up, broken plane that Luis spoke a little bit yesterday. And the solution to most of our problems, which arose time and time again, was if it doesn't perform, I'm sorry, Gavin, I just walked out of the image. I can only go here this far. If it doesn't perform, throw bigger hardware at it. And then, if it still doesn't perform, throw more hardware at it. And I could have spent about an hour on draw.io, just making this more servers and more database servers, and we just end up scaling and scaling and throwing hardware at it. And the problem is, it still doesn't solve the underlying issue, which is what Brad spoke to, that we have over time developed these monolithic, tightly coupled entities, which time and time again cause us problems and become more and more intimidating day in and day out to do anything with. So, technology evolves. We have all sorts of options available to us today that we didn't have even 10 years ago with regard to portability, with regard to the ability to effectively deploy small bite-sized portions of our application to different nodes, to different containers, to different servers, and be able to connect them all together because we've now evolved, our language has evolved, the protocols, the tools that we use have evolved to allow us to do that. So it's time for us to start breaking that monolithic cycle in the way that we look at developing apps and move toward an idea or a concept of microservices architecture. And I will tell you that it's not an easy transition, personally, because the mental model that I started developing with, it it was set in stone pretty good, and I had to change, and I had to start rethinking things, and I had to relearn some of my ideas about what good looked like in application development in order to really embrace microservices architecture. A paradigm shift is required. And a paradigm shift is defined as a fundamental change in the approach or your underlying assumptions. And if you've been developing in CFML for 10 years, or 15 years, or 20 years, you have underlying assumptions that are on top of other underlying assumptions that are layered in that lasagna of underlying assumptions. And so one of the things that you're going to find as you start looking at developing microservices of your own is that you're going to have to peel back the onion of your own ideas on what good looks like. And it will, and many of us enjoy development because we love to learn and we love to stay on the cutting edge of new things. And it gives you the opportunity to do that, but at the same time, it's not going to be easy. So we take it from big hardware to platforms as services. And these are just a few of them, it doesn't matter. We've got so many tools available to us out there. We've got Docker Swarm, we've got Google App Engine, I'm staying on this side of the podium, Kubernetes, Amazon Container Services, Heroku, which is another type of platform as a service, which actually abstracts the underlying Docker engine to another layer. So we've got tons of options out there, and I have a session later on today about platforms as services that we can dig in a little deeper on those. But the point is the tools are out there. Now, in addition to platforms as a service, we've seen this web space blow up with infrastructure as services as well. So we've got DigitalOcean, Linode, even our favorite CFML hosting providers have really gotten into that game. What, Vultr, was that the one you sent me yesterday, Andrew? So Vultr, that's another one. Some great infrastructure as service providers that allow you to very quickly develop your own platforms as services for a fraction of the cost of what you might pay to deploy on Amazon or App Engine or Heroku. So that whole space is there. It's ready for you as a developer to fill it. You just need to take a little time to understand and to dig in and really explore what's available to you and what's applicable to the type of applications that you deploy and develop for yourselves and for your clients. So that paradigm shift is, instead of developing and maintaining a large body of code, a large application, we begin the process of orchestration, of orchestrating that application with some fundamental ideas being, one, less is more. We don't necessarily have to make big things that do a lot of things. Sometimes we can make small things. And let me tell you, one of the benefits of making small things that do things really well is that you can deploy them on smaller commodity hardware and as a whole end up using fewer resources or requiring fewer resources to maintain stability of your application than you would if you package them all together in the monolith. So you might be able to reduce the requirement of your monolithic application by 1 gigabyte while only requiring 256 megabytes for that service to effectively do its job. Because that extra space there between the 256 and the 1 was all dedicated to fault tolerance. It was dedicated to making sure that this one service that you provided and packaged in your application wasn't going to bring down the whole big, hairy application. So less is more. And applications as concepts of independent parts. So we often think of those, I'm starting to squeak here, we often think of applications as collections of functions. Now we start thinking about them as collections of parts. Incremental upgrades and versioning in lieu of massive release cycles. And this is one of the things that will actually be a paradigm shift not only for you, but for your clients. Because many of your clients are used to these big release cycles where we develop, we plan and develop huge major cycles. But from an agile standpoint and from a microservices architecture standpoint, breaking things into their smallest components and deploying them separately and managing them separately allows us to have very small, short release cycles, which fit very well into an agile methodology. So, in addition, we also want to look at, one of the things that we're going to look at with regard to orchestration is hardware independence. Your applications should be portable. And one of the things that challenges that is that for so long, we've got, how many of you are run production apps on CF9? Raise your hand. How about 10? We got 10s, I'm sure. We got 11s. Okay, so how many of you have, had that one problem you had to solve and you just, threw that jar into the class path, or you had that custom tag that's like, been going from server to server to server over time. And it's this one little piece of hardware that couples you to this engine, and it also ends up coupling you to that piece of hardware because you can't easily move it. You've got to take care of all those other parts that you have managed and put in place. So one of the focus is hardware independence. And with things like modularity, using, for example, the Java Loader module for ColdBox, you can very easily eliminate all that dependence on the engine or the hardware and handle those classes at runtime or at application load. In addition, the same type of thing exists with databases. There's a lot of abstraction opportunities out there. There's the CFML ORM. There's also other great ORM products out there that have done a great job of abstracting the database layer so that you can decouple your independence on a specific server. Or on a specific DBMS, platform independence. And then also the idea of disposable instances that scale on demand and then tear down when the demand decreases. And what you will find a lot of times for these items that are pain points that you develop in the microservices is that you really only need them for a small portion of, in some cases, the day, in some cases, the week, and in some cases, the year. So, one example I use is a client of mine who has a big chocolate shop, and Easter and Christmas are a big time for them. And so in the clustering pattern and actually setting up their needs, their service needs, what we ended up doing, they have a shipping service that is one of the pain points of the application. It's constantly checking in, it runs these huge, very expensive queries. And so what we ended up doing was, because that shipping software was being hit more, is we scaled out the endpoints, the service endpoints for that, to 3 instances at Easter. We also scaled the main instance out to 4 instances, the whole of the application running. And so all of our traffic was balanced to this, this pain point service, and the public interface remained peppy, and the uptime was 100% through a very busy time. But you know what? When it was done, we just scaled it back down, and we disposed of all those instances. They're gone. We can bring them up again if we need them, and if we don't, we're good. So think about disposability. That's a hard one to do because when we have been so focused over time on hardware specific, engine specific dependence, we don't think in terms of disposability. We think in terms of permanence, and we're moving away from that. So microservices defined. Martin Fowler has a great article on his blog that talks a lot about it. If you get a chance, hop on there. It's kind of a seminal article on microservices architecture. But basically the definition that he provides is an approach to developing a single application as a suite of small services, each running its own process and communicating with lightweight mechanisms. And lightweight is one of the keys here. So let's talk a little bit about microservices. What do they do for you? And what benefit do they provide you as a developer and as someone who has to provide services to your clients? They make legacy code updates much less intimidating. Because when you're dealing with a microservice, you're only dealing with the component parts that service needs to deliver. You're dealing with the objectives that needs to deliver. And because it is broken out and is a separate part of the entity, iterations and updates on that are far less intimidating because we don't have to worry about breaking dependencies, especially if you have a good versioning strategy in mind. They also require fewer resources to maintain their fault tolerance, and they're versionable and maintainable. And think about that in terms of versioning. If you're developing microservices, That's one of the components that you want to start out with in mind is that you plan not to break your backward compatibility by versioning as you move forward. So when you release your version 2 of your service, those endpoints that still rely on version 1 can operate, and you can sunset over time those versions out there that are, you can change the endpoints over gradually. You don't have to have these massive release cycles. Short release cycles, as we spoke to already, and monolithic apps can be evolved piece by piece by piece, which means that you can take those items in your applications that are pain points that are big, and you can break them out piece by piece by piece. And so instead of having this, a lot of times we take up this big rewrite chant because we've got this application that's so painful and so expensive to develop and so difficult, and we end up, getting denied because the cost of it is so prohibitive. But monolithic apps can evolve. They can be broken out into microservices, and over time they make your lives easier. And finally, when that rewrite chant comes up to take the rest of what remains of what was once a huge monolithic, multi-layered lasagna that went across this room, we can finally, everybody can get on board and we can rewrite the remainder of it because everything else has been handled and broken out through microservices. So, from legacy CFML apps, what are the steps that we need to follow to do that? And we talk a lot about modularity. I can't say enough that certainly ColdBox is at the forefront of that with regard to CFML frameworks. There are lots of tooling that you have available to you. But let's talk about, at the big picture, what does it look like to break up a legacy CFML app? Step 1 is, first and foremost, identify the performance pain points and bottlenecks in your application. And a lot of times, your bug tracker or your bug emails, if you've got one of those applications that really cause a lot of problems, you probably have to sort through and take a look and see what's the issue here, what's not. You got to look at your bug tracker. That's going to tell you a lot of where the problems are. It's also going to, Fusion Reactor is another great tool to diagnose where those performance bottlenecks are at. So identify where the performance bottlenecks are, and then as you make a list of those, prioritize which ones are the biggest, from the highest priority to eliminate to the lowest priority. Step 2, take those performance bottlenecks, starting one little bite of that elephant at a time, and build, test, and deploy new microservices to address and deliver the functionality of those pain points independently. We're not even talking about the monolith right now. You can break that code, you can reuse some of that code, but break it out. Make it a microservice, build it, test it, deploy it, and then once you've done that, just simply update the endpoints in your monoliths to use the microservices. Eliminating probably hundreds, probably thousands of lines of code from the monolith, but also what you'll find as you deploy and use microservices is that your UI becomes much more responsive to the end user because all of that blocking behavior we were using to handle these pain points goes away. And your microservices using AJAX calls, using threading under the hood, can really make that easier for you and make everything in your application more responsive. Step 4, rinse and repeat with additional bottlenecks and pain points. So let's talk about the tool set that you have to be able to do that. So step 1, identify the pain points. Step 2, develop your microservices from those. Reuse code as you can from your BHAG, your big hairy application, and then iterate over and over again. What's our tool set look like for that? Well, first off, there are the suite of ColdBox products. And we can talk about why some of those are important. Starting with ColdBox and CommandBox. CommandBox, if you haven't spent a great deal of time with the scaffolding functions, allows you to very easily scaffold out modularity. It also makes it very easy for you to deploy applications that are modular in nature and, in essence, can be deployed as microservices at anywhere. The example being like Brad gave, the content box admin, where you can deploy that separately, you can direct traffic to that separately, and it functions as its own service out there. ColdBox itself, as a framework, is modular and more modular every day. CFconfig gives you now more portability than ever to transfer configuration between servers. So you can export that configuration of all your settings, your caches, your data sources, and everything from that ACF 2010 server that you have, right now in production, and import them into 2016. And you can export them and import them into Lucy 5 or Lucy 4.5, whatever you want to do. It gives you the ability to import and export. Basically, it creates a common language around that. And it's never been more easy or more portable to do that. So if you've got licensing, for example, like let's say those of you who are running that ACF 10 server out there, all you can just export all of that. And that license will be able to be set up into the config and will transfer into new containerized versions of ACF 10 that you deploy, because the CommandBox container can also, the CommandBox Docker container can also spool up ACF 10, 11, 2016, Lucy 4 or 5. So ColdBox Relax, which is a great tool in helping to document how your microservice will be consumed, especially if you're going to be using HTTP to make remote calls. DocBox is another tool. I didn't put that up here. And then also, there's ForgeBox. Because one of the things, we have over 300 packages up there right now and growing. There are so many people out there that can save you time in reinventing the wheel. Eric developed some really great modules that are excellent for microservices and very specific to certain problems that you'll run into or encounter when dealing with them. So ColdBox modules are an ideal way to do that. That doesn't necessarily mean that that's tightly coupled with the idea of microservices either. You have to decide what the right tool for you to use is for that service. It might be that microservice is simply a directory watcher, that you write in bash, or it might be another tool that's out there that you can incorporate in yours. But time and time again, most of the monoliths that you develop are going to be best served by bringing them into a modular framework such as ColdBox. Then there's portability. So what do we do once we've got these microservices? How do we automate and make the process easy of deploying? And that's where portability comes in. And so, for example, with CommandBox, CFconfig, and Docker, we have the ability to deploy those services anywhere. And because containers are so ubiquitous right now, you've got all these options out there for you with regard to how much you want to spend, how big you want to go, how much geographically you want to distribute your services. So there are more and more options, and those options are only evolving. So getting up to speed with this is it's an excellent time to do so. So let's talk about what containerization does for you, and why, if you want to develop microservices, you wouldn't just throw it up as an app by itself on a server where you've installed Lucy. What would you get from a container that you wouldn't get from a standalone commodity server? So what does it do? We've got some different products out there. We've got, first of all, it makes you independent of platforms or hardware. It reduces time-consuming DevOps tasks via automation. How many of you in this room build and automated, continuously deploy at least 50% of your projects, of your applications? Okay, so that right there's a huge opportunity is in the continuous integration, continuous deployment side of things. Okay, so having containerized systems reduces the time. And let me give you an example of what that looks like real quick. I can't actually log into VPN here because I was going to show you a live build process, but I can't. But let me give you an example of what that looks like. So this uses GitLab. You can use Travis, you can use Bitbucket pipelines, doesn't matter. There's lots of Jenkins, whatever. But so this uses Travis. This is an example of how we would simply package and create a Docker image from our application, push it up to a private registry, which now all of our staging and production servers can use for deployment. So this looks like a lot of gobbledygook, but basically what it amounts to is that this script right here, whenever an image is pushed to development or master, which you see on lines 4 and 5, say only development or master, Docker goes ahead and builds the image from a Docker file that I specified. And what that Docker file does is it packages all of the dependencies of the application together. It starts up the CF server, it warms it up, it applies the configuration, applies all the data source, caching settings, everything that I need, It packages them all together into one little image. It then pushes that image up in a finalized version to the private repository. And then, if you scroll down just a little bit in here, you'll see that once that's done, once we've pushed that image successfully up to the repository, and this is using GitLab, but like I said, so these tokens are already available. Once that's done, all it takes for us to actually deploy that image to staging is this little script right here. And all we're really doing is we're just going in, we're grabbing, setting a couple of variables here, and then we're making a quick connection, SSH connection into the staging server, and then we're just piping a command to the Docker swarm right there that says perform a rolling update of this application across the entire cluster and pass the authentication credentials so that we can log in with our private registry. So that's how automation makes things easy. And you can set this up manually, you can set this up in whatever you want to. So you're not coupled to something like this platform. But the point is that if you're not using automation, you're spending a lot of time and creating additional possible pain points for yourself that are completely unnecessary in this day and age. So containerization, why did I choose to animate every one of these? All right. And okay, looks like I'm back on the same slide. So the other thing too is that containerization also gives you health checks and rolling updates. So when I push that new update to staging, what that does with that one command is it rolls the update across all containers, all instances of that container running across the swarm. In this case, it's the staging server, so there's three servers, 2 workers and 1 master. And each one spools up the new container that I've specified. It pulls the newest version, and it won't pull down and start serving the new container until the health checks pass for the first time. So the old container will stay in place. If those health checks don't pass, it won't switch over. And what that does, it allows me to have completely zero downtime deployment. There's no need to restart the server and then wait for that first init call. By the time that first request hits the container, the server's up, it's spooled up, and it's running. Built-in emergency procedures and configuration settings provide better application fault tolerance. So if it becomes unresponsive, you can set restart policies for it, where it'll just restart the container and bring it back as soon as the health check passes for the first time. So those are some things that we have, some other benefits we have with containerization. We're going to wait for all these animations to, there we go. They're also portable between platforms, machines, data centers, and geographic regions. And this is becoming more and more important. So let's say you use Amazon Elastic Container Service. You have the option to be able to provide those services geographically. And you can also set up, all sorts of options to be able to distribute to the closest user available to your application. They also provide built-in security and isolation because you're only exposing certain things. And if something happens or that container is somehow compromised, it's not going to affect the resources of the host, and which means you can destroy it, fix the problem, and bring it back online again. They are transients versus singletons, which as developers is a familiar term to us. Containers are transients. They can be brought up, they can be torn down, they're available on demand, but they are not like our big servers that we're so used to in the past, singletons, in our lives as developers for that matter. So, in a nutshell, what does this mean? Isolate all the things. So instead of one big thing doing many things, we simply have many things, each doing one thing very, very well. Now, if we do this one small piece at a time, someday, soon, will look something more like this. And we can help you with the tools, and they're not only just us, but there's a lot of folks out there that can help you with, they're providing great open source tools out there for you to do your job. We can help you with all of that. But at the end of the day, your choice to embrace microservices architecture, containerization, and the new tools that are out there for you to develop and deliver great products and great applications that you're proud of, that you no longer have to, be the person that, whispers your programming language when you're in the group of other developers, that you are happy and can take a weekend free from fear of that thing crashing. That is all, at the end of the day, up to you. So, thank you for attending. We have a few minutes before our first conference, so go ahead and get some coffee, refresh your...
If you want to kill the live stream, you can show these guys the build.
Okay, so if you want to, I can show the build if you want to, otherwise if you want to grab some coffee or breakfast, that's great. But at the end of the day today, after the last session, please go into the sponsors lounge, because at that time we will be having a raffle, and we have all sorts of cool things to give away. We got 2 drones, we got $1,500 in Google credits, so that container thing you want to try out, Google App Engine, there you go. What else, Luis? You said there was, what else is going on with the raffle?
Nginx goodies.
Nginx goodies, yeah, and
Raspberry Pi, so you can build a RetroPie.
That's right, Raspberry Pi. So if you want to build your own blog server like Brad has with his Raspberry Pi, you got to be there for the raffle. So at the end of the day today, please go to the sponsors lounge, be there for the raffle. And other than that, thank you and have a great rest of the into the box. So if anybody wants to stick around, I'll connect up the VPN. I have to shut down the live streaming because it breaks it if I do. But I will show you how that build process works and how it runs. So go ahead and stop the streaming. And anybody that wants to stick around, I can show you. What's that? Have to kill it? All right, kill it.
But what we'll do is we'll record locally. Where's your mouse gone? There's